Alright, so I know I'm not here today, but that doesn't mean I can't try to help you guys as we kind of introduce and talk about this new concept, which to me really builds off your previous learnings related to proportional relationships. Okay? So, this is the first exercise on the lesson that you guys are going to be expected to work on today. And as you're looking at it, it really gives you a proportional relationship. So if you recall your work from last year, a proportional relationship is really where you take two ratios that are equal to each other. And in this case, we can assume that Paul is traveling at a constant rate because it has to be constant in order to be a proportion. So I'm going to start by putting his time over distance. Or we could do distance over time. It's up to you guys. So we could do 25 minutes for every 2 miles. So that's the time, and I'm just going to put a T over D to represent time over distance. And then in the problem, I see, and I'll just underline this, I see right here that the question is asking me how many miles Paul can walk in 137 minutes. So I know since I have distance and time, I'm going to put that new time, 137.5, and I'm going to put that over X. Because what I don't know is this, how many miles Paul can walk given 137.5 minutes. Okay, well, we can also try to fill in this table. So I just set up a proportion, which I'm hoping you guys recall something about cross products from last year. And since we're building off our last unit on solving equations in one variable, right now I really see we have an equation in one variable if I were to do this cross multiplication to set up an equation that I can solve. But before we dive into that, let's just really talk about this table. So if I'm looking in the table, I could just start by saying, well, let's double the time. So if we double 25, we get 50, but then we know we have to double the distance, which would be 4. I could also double 50, which would give me 100, and then I have to double 4, which would give me 8. So notice what I did in this table was just times by 2 repeatedly. So there I'm where I'm at so far. And then if I want, I could double 8 again. That's going to give me 16 miles, but I'm going to be at 200 minutes, which will pass or be too high for the 137 minutes that we really traveled. So let's just go up another 50. So if I make this 150, then since I increased by 4 when I moved from there to there, that was an increase of 4 miles, and it took 50 minutes to increase 4 miles, then I'm just going to add another 4, so I think this would be 12. So I know my answer, and if I'm using this table well, I hope you guys can connect that my answer has to be somewhere in between 150 and 8 and 12, because the time that I'm expected to figure out the distance for is really right in between 100 and 150. So this is a method, kind of a table method, but it's a little tricky because I'm like, well, I don't really know exactly what that could be. I could cut this in half, and so if I put another value, let's try 125. So that's smaller than 150, and again, since this was originally a change of 4, I would have to say, well, that would be 10 minutes. So in 125 minutes, I would travel 10 miles if I'm using this table to just try to reason. But I'm still not quite at my answer. So with that being said, I kind of want to go back to my original method. So we could continue with this table, and the distance, if I think about this, halfway between 150 and 125 actually is 137.5. So halfway between 12 and 10 would actually be 11. So I know in 137 minutes, we would travel 11 miles, which I can determine from my table, knowing that 137 is right in the middle of those two. Okay, but let's go back to this equation really quick and see if we can write that and use that to solve, which is just another method or another way of thinking about our solution. So if I go back to this original, maybe I'll try to shrink this down a little bit. So I'm just shrinking that. So if I take this proportion which I set up, and we mentioned this idea of cross products, so what that means, if I multiply 25 times x, I end up with 25x. And if I multiply 137.5 times 2, I would actually get 275. So if I'm right there, then I really just have a one-step equation to solve. So I could divide both sides by 25, and if we divide both sides by 25, I'm left with x on the left side of my equation and 11 on the right side. So in this case, that x represents the distance we could travel in 137.5 minutes. So I see my answer, and I kind of arrived at that in somewhat of two separate ways. Okay, so I'm just going to jump over to one other example that you're going to be working on in this lesson. So here's another type of problem you might see. So this time you're given an equation. We didn't have to set it up, and we're asked to really just fill in this table. So if I'm going to fill in this table, and let me see if I can choose other colors. Let's just try black. So if I'm filling in this table, I see that when I put 1 into this equation, 50 times 1 was 50 plus 15. That's where that 65 came from. So notice there's two variables, hours and distance, so time and distance again, and we're connecting those. So if I were to put 2 in that same equation, I'd have y equals 50 being multiplied by 2 plus 15. Well, 50 times 2 is 100, and 100 plus 15 would equal y, which in this case would be 115. We could do that with 3. 50 times 3 is going to be 150. And then if we add 15, we're at 165. So notice that I'm completing this table by filling in values. I could put 3.5 into that equation. So I'd have 50 times 3.5, which off the top of my head that's a little tricky, but 3 times 5 is 150, or 3 times 50 is 150. Half of 50 is 25. So this would be 175 plus 15 would be 190. And then we could do the same thing with 4.1, and I'll leave that to you guys. So again, we're just using a slightly different method of being given an equation and using that to fill in a table. So the big idea from this lesson is really connecting this concept of a proportional relationship. And in this case, I know a very common proportional relationship is speed, and that's what we've really been investigating, equals distance over time. So that's a common relationship that is very proportional if we're traveling at a constant speed. All right, so hopefully that helps. I'll set you loose at this point. Good luck.